This is a geometry lesson in chapter 4 on radicals. It's the second part of chapter 9, and an example of a radical is a square root. There's other types of radicals, but what we will deal with is square roots in this chapter, in this section. Square root is basically asking what number times itself will equal the number inside here. So what I mean by that is 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9. All of these numbers are called perfect squares. The reason they are called perfect squares is because you can put them inside this radical and you could say, hey, what number times itself equals 9? Well, the square root is 3. 3 is called the square root because 3 times itself is 9. 3 times 3 is 9. So the numbers inside, these are the perfect squares, and the answers, when you square root them, are on the outside. They're those numbers. So if we build a few more, we have 1 times 1, 2 times 2, 3 times 3, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, and 12 times 12. There is an infinite number of perfect squares. There is an infinite number of perfect squares, but these are the common ones that we will use. So the perfect squares go inside the radical. They go inside here. And then the answer, or the square root, comes out here. They're these numbers. These numbers are the ones we're interested in because they're square roots. The square roots of perfect squares come out to be these pretty integers. So the numbers in green that are highlighted give us nice, pretty integer answers. That's why we focus so heavily on them. So our goal in this lesson is to simplify radicals. Now what we need to do is figure out which of those numbers, that big list of numbers that we just came up with, which one will go into or divide 50. Now what I'm going to say is start halfway. On the top of your paper, you might want to write 4, 9, 16, 25, 36, 49, etc. if you are going to forget them. When I say start halfway, what I mean is take 50 and divide it by 2. Start testing numbers at 25 and go smaller. 25 is the biggest number that we can possibly divide 50 by. A different way to think of it is we at least have to cut 50 into 2 parts, otherwise it's pointless. If we do anything smaller than 2, for example, 50 divided by 1 is 50, this is useless. That's useless. Start dividing it in half and it gives you a starting point, okay? So 50 divided by 2 is 25. Look at that, 25 is in our list. So what we're going to do is change this into the square root of 25 times 2. Hopefully you agree 25 times 2 is still 50. 25 can have its own square root, and so can 2. So we have split them into 2 pieces. And the square root of 25, if we check our first page of notes, is 5. So this is 5 times the square root of 2. This is our simplified radical. So for our second one, we're going to take 48 divided by 2. Which is 24. So we need to start at 24, which would be like right about here. So we're going to start by dividing by 16. That's the first number in our list. So 48 divided by 16. That equals 3. Well, that's a perfect integer, so let's split this into the square root of 16 times 3, which is the square root of 16 times the square root of 3. And the square root of 16 is 4. The square root of 3 is just the square root of 3. So that one is simplified. The next one, we'll do 24 divided by 2 is 12. So if we look in our list, 12 is somewhere between 9 and 6. It's somewhere between 9 and 6. So we'll start dividing by 9. 24 divided by 9, when you do that in your calculator, it gives you garbage. It's a decimal, no good. So we go to the next one, 24 divided by 4. 24 divided by 4 is 6, so that's a good one. We're going to go square root of 24 is the same as 4 times 6, which is like the square root of 4 times the square root of 6. Square root of 4 is 2 times the square root of 6. So we were using these combinations to split up here.